We live in a weird universe, and it's full of weird stuff on a scale that the human mind cannot fully comprehend. From the enormous structures of galaxies to the most powerful explosions, the hottest planets, the coldest moons, and the unknowable mysteries inside of a black hole to the very edge of the universe itself. This is the kind of stuff that will make you question everything. There is nothing more unsettling than the unknown. And this is what defines ʻOumuamua. It is an interstellar object, which means that it came from a place outside of our solar system. But the scary thing is that we don't know where exactly that is, or how this object was created. What we do know is that it has a very weird shape, long and narrow like a cigar, and tumbling end over end as it travels through the galaxy. ʻOumuamua is the first interstellar object ever detected. And we say object because it doesn't look or behave like an asteroid, but it also doesn't look or behave like a comet. It's something else, something alien. It could have even been made by aliens. That's what a lot of people believe. And they could be right for all we know. The interstellar object was our first taste of what lies beyond the edge of our solar system, out there among the stars of the Milky Way. Oumuamua reminds us of how little we know about our own galaxy. But one thing that we can say for sure is what's at the center of it all. The heart of the Milky Way is a supermassive black hole. We call this one Sagittarius A. It's about the same size as our own solar system, but that mass of the black hole is estimated to be equal to about 4 million times greater than our sun. This creates a force of gravity so strong that nothing can escape, not even light. Anything that crosses through the black barrier will be lost to the observable universe. Inside the black hole, there is no reference for time, space, or mass. Everything is infinite, and all matter is stretched out like spaghetti as it's pulled down into the center and crushed into a point of infinite density. This is the singularity. We don't know how it works. None of the laws for space and time that exist outside of the black hole apply to the singularity, but we know that it's out there waiting for us. And if that wasn't weird enough, the really scary thing about black holes is that there doesn't seem to be any limit to how big they can grow. The black hole at the center of our galaxy might seem enormous compared to the scale of the Earth, but it's actually small on the scale of the universe. TON 618 is one of the largest black holes ever discovered. It's 66 billion times more massive than our sun, which is actually heavier than the entire Milky Way galaxy combined. It's really far away, though, 18 billion light-year. So, nothing to worry about. When you think about what it takes to become an astronaut, you imagine years of training, precision, and the ability to stay calm when everything is on the line. That's exactly what Chris Hadfield teaches in his class on space exploration on Masterclass. Hearing him talk about how astronauts prepare for the unknown really changed the way I think about solving problems here on Earth. It's not just about reacting quickly. It's about staying curious, staying adaptable, and always learning. That mindset has even shaped how I approach this channel. When I'm putting together an episode on something like the next generation of rockets, I try to think through the challenges the way Hadfield describes. Break big problems into smaller ones. Focus on what you can control, and stay calm under pressure. It's surprisingly relevant outside of space travel. What I love is how easy it is to learn from people like him. Masterclass has over 200 classes across science, tech, writing, leadership, and more. You can stream lessons anytime, anywhere, or switch to audio mode and listen like a podcast. Plans start at just $10 a month, billed annually, and new classes are added every month. It's a great way to replace mindless scrolling with something that actually helps you grow. During this holiday season, you can get up to 50% off an annual Masterclass subscription. Just click the link in the video's description or scan the QR code so they know we sent you. Learn from the world's best to become your best with Masterclass. If you did want something to worry about, though, you might be alarmed to hear that our galaxy is on a collision course. Our closest galactic neighbor is called Andromeda, and every day it gets a little bit closer. Eventually, the force of gravity will pull the two galaxies into each other. But this is actually less of a collision and more like a galactic merger. You see, space is really big, and it's mostly empty. So it's very unlikely that any stars or planets from the two galaxies will actually crash into each other. So if it happened today, you probably wouldn't even notice until you looked up at the stars and noticed a totally rearranged night sky. Not that any of us will be around to see it. The galactic collision is anticipated to happen sometime between 4 and 5 billion years from now. If colliding with one galaxy wasn't enough, we're also being pulled into a massive train wreck of galactic chaos known as the Great Attractor. This is an invisible and unexplained force that is pulling galaxies in like a cosmic vacuum cleaner. And right now, it has us and our local group of about 1,000 galaxies caught in its pull. The reason you can't see the Great Attractor is because it's located on the other side of our galactic center, which is that giant black hole. We can't see through it, and we call that the zone of avoidance. But the source of this attraction is thought to be a massive concentration of about 100,000 galaxies called the Shapley Supercluster. It's the most dense area of space in our local universe. That incredible mass creates a force of gravity powerful enough to just pull in more and more galaxies to create even more mass and continuously grow the cluster to an unfathomable size. And that's just a small taste of the massive structures within our universe that we can't fully see or understand. Running opposite to the galactic supercluster is the great nothing that is the Booty's Void. It's an unexplainably empty region of space that lies 700 million light-years away. The void contains just 60 galaxies in a region of space that would be expected to hold about 2,000. It's the largest of several voids that exist in our local area of the universe, and they're thought to have formed from small pockets of uneven gravity that emerged after the Big Bang and then grew out as the universe expanded. But we're not exactly sure what keeps them so empty. This balance between superclusters of galaxies and giant voids of nothing starts to reveal the shape and structure of our universe. Space isn't random or even, it's being formed into something. A lot of scientists have pointed out that the structure of the galaxies seems to resemble the neurons of the human brain. That could just be our natural inclination to see familiar patterns in abstract things like those ink blot tests. Or it could be a sign that there is something at work in the universe beyond our ability to comprehend. While we contemplate the great nothing, let's talk about the star that just disappeared from the night sky. In 2009, astronomers had their telescopes locked in on a star in the constellation Cygnus that they believed was in the final stage of life. That star, which was either a red supergiant or a yellow hypergiant, had increased in brightness by 1,000,000 times in just 3 months of observation. So, what they were expecting to see next was one of the most powerful events in the universe, the explosive death of an ancient star, what we call a supernova. But instead, the star simply vanished. Astronomers are still not entirely sure what they saw, but it's definitely proof that the universe behaves in much stranger ways than we understand. It's possible that the star just didn't build up enough energy to explode and just kind of fizzled out. It also might have collapsed straight into a black hole. What we typically look for in a supernova is a giant star that is on the verge of running out of atomic fuel. Think of a star like a giant nuclear fusion reactor. It's using gravity to constantly squeeze atoms together and form new elements that get increasingly heavy as time goes on. As long as the star can keep fusing more atoms, it generates enough energy to balance out the incredible mass that builds up inside the core. But when it runs out of fusible atoms, gravity begins to take over and the star collapses under its own weight. The recoil from that collapse, or the equal and opposite reaction, as Newton would say, is a massive explosion. The energy released from a supernova will obliterate everything within 30 to 50 light years. After the explosion, only the heaviest elements in the core of the star will remain. And then that core will collapse under its own weight again, this time becoming so dense that it forms a new black hole. Our next opportunity to catch a supernova in action is probably going to come from a star named Betelgeuse. It's a red supergiant that is believed to be on the edge of collapse. When Betelgeuse does explode, it will appear as bright in our sky as the full moon. so you won't even need a telescope to see this one happen. The only problem is that the lifetime of a star is a lot longer than a person. So, when we say the star is near death, that means it could still take another 100,000 years for the supernova to happen. And no, you shouldn't be worried. Betelgeuse is 650 light-years away. So, we're well outside of the blast zone. The cool thing about space is that you don't actually have to go very far to find something weird. There's plenty of strange occurrences right here in our own solar system. And one of the most fascinating is the methane rain of Saturn's moon Titan. In spite of the name, Titan is only the second largest moon in the solar system. It's about 50% larger than our own moon. And that means Titan is able to hold onto a thick atmosphere. It's actually pretty similar to the Earth. There are clouds that form and rain down liquid onto a surface that's covered by rivers and lakes. Only this isn't water. It's methane. On Earth, methane is always found in the form of a gas. We typically call it natural gas. But out here in the deep solar system, the temperature plunges to nearly 300 degrees below zero. And inside the atmosphere of Titan, that cold will turn methane into a flowing liquid. That makes Titan the only other place in the solar system aside from Earth to have a stable liquid on its surface. So what you get is the same hydrological cycle of evaporation, condensation, and precipitation that we know so well, just recreated in a totally alien way. And if you think that's weird, here's what happens when the conditions are totally opposite and a planet gets super hot instead of super cold. We're looking at an exoplanet named Kepler-10b. It's very far away from our solar system, about 560 light-year. And even though this planet is a similar size to the Earth and made of a similar rock, it exists in a much different solar environment. Kepler-10b is parked right beside its host star, just 0.002 of the distance between the Earth and the Sun, and about 20 times closer than the distance from Mercury to the Sun. The result is that Kepler-10b gets cooked. The surface temperature is estimated to reach over 1,300 degrees Celsius. And when a rocky planet hits that temperature, it's believed that something really weird starts to happen. Lava rain. Not only would the surface be covered in molten rock, the heat from the star would actually be able to vaporize lava and cause it to evaporate up into the clouds, where it would condense into liquid rock and fall from the sky. Maybe the weirdest place of all is the edge of the universe, or the edge of the observable universe. That is in theory. There's no end to space, just infinity in all directions. But there is an end to how much of that infinite universe we are able to see from the Earth. It's a line that is 46 billion light-years away. And beyond that edge is light that will never reach the Earth, even if our planet continued to exist for infinite time.